The Arctic night descends like a predator, silent and absolute. At negative 40 degrees Celsius, the air itself becomes a weapon. Exposed skin freezes in under 2 minutes. Breath crystallizes before it leaves the lungs. This is not a place where humans should survive. Yet for thousands of years, the Inuit people have not merely survived here. They have thrived. Their secret lies in a paradox that seems to defy logic. They built shelters from the very element trying to kill them. They turned ice into insulation, snow into sanctuary, and cold into comfort. The igloo stands as perhaps the most elegant engineering solution ever devised by human hands. To understand its genius, you must first understand what it means to face the Arctic cold without it. When the temperature plummets and the wind begins its relentless assault, a human body loses heat at a catastrophic rate. Without shelter, death comes in hours, sometimes minutes. The Inuit hunters who traveled vast distances across the sea and ice could not carry heavy tents or drag sleds loaded with wood through a landscape devoid of trees. They needed shelter they could build anywhere, from materials available everywhere. They needed the igloo. The construction of an igloo begins not with cutting blocks, but with reading the snow itself. This is critical knowledge that separates the expert from the dead. The Arctic does not provide one uniform type of snow. There is powder snow, light and useless for building.
Now this is
There
what you look
wind-packed
for.
Snow, hard
Strong
but
cohesion
brittle.
and high density.
What the builder
This drift
seeks
will give us
is what the
excellent
Inuit
building
call
material.
pukak in some dialects. Snow that has undergone specific transformations. The ideal snow has been deposited during particular weather conditions, then compressed by wind into a material with a crystalline structure dense enough to be carved, yet cohesive enough to hold its shape. The builder walks the landscape, probing with a thin rod made of antler or bone, feeling for that perfect consistency that lies beneath the surface. When the probe sinks to a certain depth and then meets resistance with just the right texture, the hunter has found the quarry. The tool used to harvest these blocks is the snow knife, traditionally carved from bone or ivory, now often made from metal. The blade is long, sometimes reaching 3 feet, with a slight curve that allows the cutting motion to create blocks that naturally taper. The first cut is the most important. The builder slices into the snow at a precise angle, creating blocks that measure roughly 2 feet long, 15 inches high, and 8 inches deep. But these are not uniform rectangles. Each block tapers slightly from bottom to top, from outside face to inside face. This taper is the key to the entire structure's stability. The construction site is chosen with care. The builder seeks a location where the snow is deep and of good quality, but also where the prevailing winds will not directly assault the entrance. Often, the igloo is built partially into a snowdrift, using the natural topography to provide an initial windbreak. The first blocks are laid in a circle, the diameter determined by how many people the shelter must hold. A small igloo for 1 or 2 hunters might be 8 feet across. A larger dwelling for a family could reach 15 feet around. Now, the most crucial moment comes after the first ring of blocks is complete. This is when the builder makes a cut that seems counterintuitive. Using the snow knife, the builder slices diagonally through several of the first blocks, creating a ramp that spirals upward. This transforms the construction from a series of horizontal layers into a continuous ascending spiral. Now the engineering brilliance begins to reveal itself. As each new block is placed, it rests not only on the block beside it, but also on the one below, creating a structure that supports itself through the principles of core billing and compression. The taper of each block means that as they spiral upward, they naturally curve inward, forming a dome. The builder works from inside the structure, shaping each block with a snow knife before sliding it into position. The fit must be precise. Gaps mean cold air intrusion and structural weakness. The builder uses loose snow, mixed with a small amount of water if available, to seal the joints. In the intense cold, this slush freezes almost instantly, creating a bond that is stronger than the blocks themselves. As the dome rises, the angle of each successive block becomes steeper. This is where experience and intuition guide the builder's hands. The blocks must continue their inward curve without collapsing prematurely. About 2/3 of the way up, the structure reaches a critical point. The dome is incomplete, yet it must already be strong enough to support the weight of the builder moving inside it. The final blocks at the top, called the boss or keystone blocks, are the smallest and must fit with absolute precision. The builder shapes the final block from outside, then carefully lowers it into place from above. When this block seats properly, its weight is distributed equally around the entire dome, locking the structure into a self-supporting arch. The igloo can now bear tremendous weight. Polar bears weighing over 1,000 pounds can walk across the top without causing collapse. But the structure is not yet complete. The entrance is critical to the igloo's thermal efficiency. The builder constructs a tunnel extending from the base of the dome, sloping downward below the level of the interior floor, then rising back up to emerge outside. This creates a cold sink. Since cold air is denser than warm air, it flows down into this entrance tunnel and remains trapped there, while the warmer air inside the dome stays elevated above this layer. This single architectural feature can create a temperature difference of 40 degrees or more between the outside environment and the interior sleeping platform. When outside temperatures reach -40 Celsius, the inside of an occupied igloo can climb to 0 degrees or even slightly above freezing, all with no fire larger than a small seal oil lamp.
Snow is remarkably
The thermal
light
properties
because
of
it is
snow itself
composed of up
are
to
the foundation of
90%
this
trapped
miracle.
air. This
Snow
intricate
is not
matrix
solid ice. It is a matrix of ice crystals with air trapped between them. Air is an excellent insulator because it does not conduct heat well. The snow blocks of an igloo can be 90% air by volume. This makes them remarkably effective at preventing heat transfer. When human bodies occupy the space inside, along with a small cutlet lamp burning seal or whale oil, the heat these sources produce cannot easily escape through the walls. The temperature inside rises, but the snow walls remain cold enough on their outer surface that they do not melt away in the Arctic air. However, the interior surface does begin to melt slightly. This is not a flaw, but another engineered feature. As the warmest air inside the dome contacts the inner surface of the snow walls, a thin layer of ice forms. The builder anticipates this, and may even accelerate it by using the lamp to glaze the interior. This ice layer creates an even more impermeable barrier to air movement and adds structural strength. The walls become harder, more permanent. An igloo properly constructed and maintained can last for months, growing stronger as its walls transform from compressed snow to layered ice. Ventilation is the next critical concern. A completely sealed igloo would suffocate its occupants as they consumed oxygen and produced carbon dioxide. But simply cutting holes in the dome would destroy the thermal efficiency. The solution demonstrates another level of sophisticated understanding. The builder creates a small ventilation hole at the top of the dome, typically no larger than a fist. This hole allows air to circulate without creating significant heat loss. The warm air rising inside the dome creates a slight positive pressure that pushes stale air out through this top vent, while fresh cold air is drawn in through tiny gaps deliberately left unsealed in the entrance tunnel. The movement is constant but gentle, providing fresh air without the devastating heat loss that would come from large openings. The interior of the igloo is organized with the same attention to thermodynamics. The floor is never level. The builder excavates the center to create a lower cooking and working area, then leaves an elevated platform along the rear wall. This platform becomes the sleeping area. Since warm air rises and cold air sinks, the sleeping platform exists in the warmest zone of the dome. Families place caribou hides, bear skins, and layers of dried grass on this platform, creating a nest that further insulates them from the cold. The difference in temperature between the lower floor and the sleeping platform can be 10 degrees or more. Children and elders, most vulnerable to cold, sleep in the center of the group, surrounded by the body heat of adults. The Kudlik lamp deserves its own recognition as a masterpiece of technology. Carved from soapstone into a crescent or oval shape, the lamp burns seal or whale oil with a wick made of Arctic moss or cotton grass. The oil burns with a flame that is surprisingly warm and smokeless when properly adjusted. The lamp provides light during the months of polar night when the sun never rises. It provides enough heat to warm the igloo interior and dry wet clothing. It serves as a cooking surface where frozen meat can be thawed and snow melted for drinking water. But the management of the lamp requires constant attention. The wick must be tended, the oil level maintained, the flame adjusted to prevent smoking while providing maximum heat. This task traditionally fell to the women of the household, and it was a responsibility that required years of experience to master. A poorly tended lamp could fill the igloo with toxic smoke, waste precious fuel, or provide insufficient heat. A well-tended lamp could keep a family alive through the darkest months of winter. The clothing worn inside the igloo is as carefully engineered as the structure itself. The Inuit understood that warmth comes not from heavy layers, but from trapped air. They wore 2 layers of caribou skin clothing, with the hair facing in on the inner layer and facing out on the outer layer. This created an airspace between the layers that provided remarkable insulation. Inside the igloo, as the temperature rose, they
The
could
dry
remove the
fabric
outer
remains
layer
warm
to
and
prevent
lofted, but the
overheating
wet
and
sample is
sweating.
now a block of ice. This demonstrates
Sweat
why
is
managing
deadly in
sweat
the
is
Arctic.
essential for cold weather survival.
Moisture in clothing destroys its insulating properties and creates a direct pathway for heat to escape the body. Yet the Inuit learned to regulate their temperature precisely, adding or removing layers, adjusting their activity level, managing their microclimate with the same precision they used in building the igloo itself. The snow used in construction does more than insulate. It also provides acoustic dampening. The howling wind that can reach hurricane force outside is reduced to a whisper inside the dome. This creates a psychological sanctuary as important as the physical one. The sound of the wind in the Arctic is not just noise. It is a constant assault on the nervous system, a reminder of the hostile environment trying to kill you.
This
Inside
carving
the
tells
igloo,
the story
that
of our
sound
journey
fades.
across the ice.
Families can talk,
Do you see the
tell
markings
stories,
here?
sing,
Yes, I
and
understand
maintain
now.
the social bonds that are as essential to survival as food and warmth. The elder can pass knowledge to the young without shouting over the gale. The hunter can rest without the auditory assault that prevents deep sleep. When morning comes, or when the storm passes, or when the hunting demands movement, the igloo is not simply abandoned. A skilled builder can construct a functional igloo in under 2 hours. But that same builder might also return to a previously built structure if the travels bring them back to that location. The igloo does not decay like wood. It does not blow away like a tent. It stands until the spring melt or until the wind finally erodes it away. Some igloos built in particularly cold regions, where temperatures never rise enough for significant melting, have stood for years, becoming landmarks in the otherwise featureless white expanse. The knowledge required to build an igloo is not instinctive. It must be taught, practiced, and mastered through experience. Young
Keep
Inuit
the angle
boys
low,
will begin learning by
like
watching
this,
their fathers
to get
and
that
uncles,
smooth finish.
Okay,
then
I
building
see.
small practice domes, then gradually taking on more of the work until they could construct a shelter entirely on their own. This knowledge represented survival itself. A hunter who could not build an igloo was a hunter who could not travel far from established camps, who could not pursue game across the sea ice, who was forever limited in his ability to provide for his family. The igloo was freedom. It was safety. It was the technology that allowed human beings to inhabit one of the most hostile environments on Earth. But the igloo is not just historical. Even today, the Inuit hunters traveling on the land sometimes build igloos when circumstances require it. Modern materials like insulated tents and portable heaters have made life easier, but they can also fail. Batteries die in extreme cold. Fabric tears in high winds. Fuel runs out. The igloo requires none of these things. It needs only snow, a cutting tool, and knowledge. It is failure-proof technology in an environment where failure means death. This is the ultimate measure of design excellence. Not complexity, not comfort, but absolute reliability when everything else has failed. The physics behind the Igloo's success can be quantified with modern instruments. But the Inuit understood these principles through observation and experience long before the laws of thermodynamics were written in textbooks. They understood that air was an insulator. They understood that a curved structure distributes stress more effectively than a rectangular one. They understood that warm air rises and cold air sinks. They understood that wind accelerates heat loss and that any barrier to wind provides protection beyond its insulating value alone. They did not need equations to prove these truths. They needed them to survive, and so they learned them with a completeness that academic study can rarely match. Consider the alternative approaches that might seem logical to someone unfamiliar with the Arctic. Why not build with ice instead of snow? Ice is stronger, more permanent, and readily available. The answer reveals the Inuits' sophisticated understanding. Ice is too dense. It contains little trapped air and therefore insulates poorly. A structure made of solid ice would be cold inside, barely different from the outside environment. Snow with its air pockets is the superior material. Why not make the igloo larger for more comfort? The answer again demonstrates wisdom. A larger dome requires more body heat and lamp fuel to warm. It has more surface area through which heat can escape. The Inuit built their igloos just large enough for the task, no bigger, because every extra cubic foot of volume was volume that had to be heated and maintained. The entrance tunnel, often overlooked in simple explanations, is itself a marvel. It serves multiple functions simultaneously. It provides the cold trap that preserves interior warmth. It creates a barrier to wind that would otherwise blast directly into the living space. And it provides a workspace where activities that might introduce moisture or cold into the main dome can be conducted. Wet clothes can be beaten free of ice in the tunnel. Fresh meat can be stored there where it will stay frozen but accessible. The tunnel can be blocked with a snow block during severe storms or at night, creating an additional barrier to heat loss. Some tunnels include small side chambers for storage or as emergency sleeping areas. The tunnel is not an afterthought, but an integral component of the shelter system. The seasonal variations in igloo construction also reveal deep knowledge. Winter igloos, built on sea ice or frozen ground, could be temporary structures meant to last days or weeks. These were
This
smaller,
seasonal strengthening
simpler,
technique
designed for
involves
hunting
creating a
expeditions.
robust ice
Spring
coating.
igloos,
It protects
and
the
built
igloo
as the
walls
days
from the
lengthened,
warmer.
temperatures began to rise slightly, might be reinforced with water poured over the exterior that would freeze into an armor of clear ice. Summer, when temperatures rose above freezing and snow became unavailable, required different shelters entirely. Tents made from caribou or seal skins. When the first snows of autumn arrived, the Inuit returned to snow construction, building progressively more permanent structures as winter deepened. The largest igloos, sometimes
The hydroponics
interconnected
unit
into
handles
clusters
nearly
with shared
80%
tunnels,
of our produce.
served as winter villages
incredible.
where
And it
multiple
integrates
families lived
so
in proximity,
seamlessly.
sharing resources and labor while maintaining individual family spaces. The spiritual dimension of the igloo cannot be separated from its practical function in traditional Inuit culture. And the snow was not merely material, but part of the living landscape, a gift that sustained life. The act of building was accompanied by awareness and respect. The shelter provided by the igloo was understood as part of the balance between human needs and environmental forces. This perspective, whether framed in spiritual terms or ecological ones, reflects a profound truth. The Inuit survived because they worked with their environment, not against it. They did not try to impose alien technologies on the Arctic. They did not attempt to create tropical warmth in a polar climate. They created sufficiency, safety, and comfort using what the land provided in a way that did not deplete or damage that land. Modern engineers studying the igloo have found themselves humbled by its efficiency. Computer models analyzing stress distribution, thermal dynamics, and material properties confirm what the Inuit
The
knew
analysis
through
confirms
practice.
the geodesic structure is
The dome
optimal.
shape is optimal.
The elegant spiral,
The spiral construction method is elegant and sound. The ventilation system is perfectly balanced. The entire structure represents a solution to multiple complex problems simultaneously. Structural integrity, thermal retention, moisture management, ventilation, ease of construction, material availability, and repairability. It does all this with zero manufacturing components, zero external energy input, and zero environmental impact. When the igloo melts, it leaves nothing behind but water, returning to the very element from which it was built. The future of traditional knowledge like igloo
Faster, hike!
construction exists at an interesting
Move
crossroads.
away from the edge!
Climate change is altering the Arctic dramatically. The sea ice forms later.
The
and
disruption
melts
of
earlier.
traditional snow patterns
Snow
means
quality
less
and
insulation
quantity are
and
changing.
altered water availability
Traditional
for these
hunting
delicate
patterns
alpine
are
plants.
disrupted. Younger generations are more likely to live in permanent settlements with modern housing than to travel the land as their ancestors did.
Our ancestors
Yet
understood
there is
the
also
balance
renewed
required for
recognition
true
of the value
resilience.
of indigenous
This weaving
knowledge,
technique, for example,
both for
is
its
both
own
efficient
sake
and
for
sustainable.
what it can teach about sustainability, efficiency, and resilience. The igloo stands as a symbol and as a practical tool. It represents human ingenuity at its finest, not the ingenuity of complexity and industry, but the ingenuity of simplicity, observation, and adaptation. When you understand what an igloo truly is, not just a snow house, but a complete environmental control system built from frozen water, you begin to appreciate the depth of human capability. So the Inuit did not survive the Arctic by accident or through some genetic adaptation to cold. They survived through knowledge, accumulated over generations, tested in the most unforgiving laboratory imaginable.
By adjusting the
Every
parameters
mistake was
here, we
potentially
ensure the
fatal.
failures are eliminated
Every
before the next
innovation that
iteration.
worked
I
was
see.
remembered
So this is how
and
we
taught.
pass the successful data forward.
The igloo is the result of this process, refined over thousands of years into a technology so effective that it seems almost miraculous. They beat the cold not by generating massive amounts of heat, but by conserving the small amount they had. They turned the enemy into an ally, building their walls from winter itself. And in doing so, they demonstrated a truth that remains relevant today. The most powerful solutions often come not from fighting nature, but from understanding it deeply enough to work in harmony with its laws.